Hello there! Today I will do a practical strength dimensioning experiment. I will soon be ready with the two hulls and then I will start working on the cross beams. And for that I need to have thought through how to construct the cross beams. I have a rough idea, but I want the cross beams to be as light as possible. So thus I want to reduce the amount of material that I will use in the cross beams as much as possible, while still having enough strength for them. So today we will do some testing. In the test construction I will use 9mm thick strips. Thus I cut out 2 cm wide strips from a spruce board, until I have a 7.5 cm thick pile of strips. The test construction will be compared to a solid plank of the same height and width. I start gluing the strips on the mold covered in masking tape. The mold is curved to form an arc spanning 205 cm. The height from the base is 12 cm. I glue one strip at a time and then clamp it down and continue until all layers are in place. The day after I can cut the ends flush and remove the bow from the mold. Outside I set up 2 sawhorses 170 cm apart. First I will test a straight solid board 7.5 cm high and 2.2 cm wide. To stop the plank from falling over, I stabilize the ends. I place a balance on the middle point and a basket for a load on its end and secure the balance so it will not break. Now I can start loading stones into the basket. But the plank bends down so that the load starts resting on the ground. So I will have to change the setup. I raise the height of the sawhorses and extend the span width to 200 cm to reduce the weight needed to break the plank. Now I can start filling up the basket again. Now you could perhaps hear the wood fibers cracking. And here you can see them crack at about 100 kilos. Now I will test the actual beam prototype and start loading stones again. The beam will only need to carry 90 kilos, but this glue-lamp beam should be able to carry much more than that. Of course, the gluing isn't perfect. You can see gaps in the construction, and I used broken pieces for 2 of the layers. So this should be the worst case example. If this holds 90 kilo, the cross beam should at least hold 180 kilo. As I will have 2 beams of this size connected for each cross beam. The span width will also be less than 200 centimeters, around 170 centimeters. Watch, this doesn't break. Instead the beam flips around. So my conclusion is that the test is successful. The beam carries at least 90 kilo when it flips. But I might consider reducing the height of the arc, as it's unnecessarily high. So now I can proceed with the beam construction. Please join me next time as I proceed with the build.